Next, I want to cover karst and geothermal. And these are chapter 17. We're going a little bit out of order with the lectures, but coming back to karst. So what is karst? And what it is these are things that form underneath the ground because of water dissolving away rock material. Now this is different than erosion. It's not washing it away, it's literally dissolving material away. So if you've ever seen caverns, sinkholes, that sort of thing, those have to do with karst. And one thing unique about them is that you find them in humid landscapes, wet environments, because you need a lot of water, and also in wet environments there's a lot of vegetation. The vegetation actually helps to make the water a little bit more acidic and makes it more of a powerful dissolving agent. And secondly, the other thing covered in this chapter is geothermal water. And this is water that's heated by rocks underneath the ground. So maybe not necessarily magma itself, could be magma, but perhaps rocks that are heated by magma underneath. The rocks get so hot that it heats up water underneath the ground, and they can blast out into the surface as a geyser or a steam vent, or what's called a fumarole sometimes. But this is water that's underground water that's heated usually because there's some sort of magma chamber or something like that, some sort of volcanism underneath the ground. All right, so a little background on karst. So in the past we talked about chemical weathering. And one example of chemical weathering is carbonation. Carbonation is where carbon dioxide mixes with water, and it makes the water slightly acidic. And depending on the material, and this is important here, limestone is a type of rock that can be easily dissolved by an acid. So water that's acidic will dissolve limestone. If you recall watching that Ring of Fire video where the guy was testing a rock and he poured a little acid on it and it fizzed up, he could tell it was limestone because it was reacting to the acid. So groundwater is a weak acid and has carbon dioxide in it. It gets carbon dioxide from the atmosphere and it's mixed in the water, and it makes the water slightly acidic. And what it causes is it causes dissolution. Dissolution is like dissolving, and it's the removal of bedrock through chemical weathering. And again, it's mostly in humid environments. It's effective on carbonate, sedimentary rocks, and particularly, I want you to know this, limestone. Limestone has a lot of calcium in it. Limestone is actually made of dead sea creatures, and dead sea creatures have calcium like we have in our bones, and that calcium can be easily dissolved and it's a big part of what makes up limestone rocks. Limestone rocks are from seafloor deposits. Now there is an opposite of that. So just like there is erosion and then deposition, there is an opposite of dissolution. There is precipitation. And precipitation is what it means is when material that's been dissolved turns back into solid material. So if you look at a cavern, you have two things going on here. One, the cavern material gets dissolved away, empties out the cavern, but then as water is dripping into the cavern, some of it will come back into solid material, and that's why you have these different hanging and features that are hanging from the ceiling, coming up from the floor. That's because as the water drips, there is this very, very slow process of material coming back into solid form. It can take thousands of years to create these features. And one place you have a lot of precipitation is in hot springs. So hot springs are where you have geothermal water, which we'll talk about in a moment. But because hot water is a better solvent, things can dissolve easier in hot water, when the hot water comes out, it has a lot of dissolved material. And if you look here, this is from Yellowstone, where all this stuff is stuff that precipitated after the water cooled down after coming out of the ground. Here's another photo example with things that are hanging from the ceiling. The cavern itself got cleared out through dissolution, and precipitation caused the hanging and the features in the ground, the stalactites and stalagmites. And so landscapes that are created through this dissolution and precipitation process are called karst. It comes from the name of a place in Eastern Europe that has this kind of topography, a lot of collapsed caves, caverns, sinkholes, that type of thing. And so we just call this karst environments. This is showing where there are karst environments in the world. One thing you want to have is limestone, but it's not just limestone. Here in the Sahara, there's lots of limestone, but there's not enough water. So you need both limestone and a wet environment. The one thing that we might be familiar with that's a karst landform is sinkholes. So if you've heard of sinkholes in places like Florida where the ground opens up and stuff falls into the ground, that's caused by karst. So underneath the ground, the limestone is dissolving away, and it can be undermine the surface, causing it to collapse into a sinkhole. This is where there's karst environments in the United States. And if you look at one state in particular, boy, look at Florida. Florida is probably the state that is most affected by karst. There's different kinds of sinkholes. Solution sinkhole is one that dissolves from the top down. So the water sits on the top and just slowly kind of dissolves downward. A collapse sinkhole is much more dangerous. In this situation, the dissolution is taking place underneath the ground, and then that can weaken the surface, causing it to suddenly collapse. So this is a solution sinkhole here, where it's just sort of slowly kind of dissolving downward. And this is a much more dangerous situation of a collapse sinkhole. And this is a house in Florida where part of the house actually collapsed into the sinkhole. I believe took a person with it who was never found because they were kind of pulled into the sinkhole as well. Tragic situation, very dangerous. And these environments evolve over time. So initially what you have is some caverns that are developing underneath the ground as the limestone dissolves. Over time, and so this is stuff that's dissolving below the water table. So remember, the water table is the top of the groundwater. And then over time, as you get sinkholes and collapses, it changes the landscape until you eventually, all you're left with are what you call these haystack, these weird little mounds of hills that are the only thing left. And you've worn down all the way through the limestone to shale, which is a different kind of rock which doesn't dissolve as easy. So these are haystacks in a rainforest environment, and you get that weird otherworldly look because of the type of dissolution that's happening. In some cases, you can have these tower karsts, which are sort of large mountains that you find associated with karst that are kind of off by themselves as little towers.